Welcome to a brief overview of xaitControl. I will be providing you with a full demo of both the tool and the runtime, but I'd like to first show you one brief slide to explain just a few highlights of the product.
xaitControl is a final state machine, which means it's a kind of if, then, else, maybe machine that allows you to create, modify and maintain reactive behaviors in a flow graph-based graphical user interface. xaitControl is hierarchical, which means you can use state machines within other state machines. This feature allows you to create simple, easy to understand state machines and stitch them together to create more expressive, more believable behaviors in state machines. Usually state machines are pretty static, so for same inputs you will get same outputs, and this would result in a pretty artificial behavior. So xaitControl allows you to assign probabilistic values to get a little bit of variation in your behaviors. Furthermore, xaitControl is completely data-driven, which means there is no need to restart or recompile your game after you make changes to your AI, which will save you time. Last but not least, this graphical approach is easy to learn, easy to understand, and easy to maintain. But even the easiest systems are a little bit error prone, so you need a way to debug your AI. And xaitControl allows this by its integrated graphical debugger. Now let's see what you can achieve with xaitControl.
We've created here a little street fighting scenario where a bad guy attacks another character. We'll call the bad guy later on Alpha and the character that is attacked Beta. So now let's watch this a little bit closer again. So Alpha is approaching Beta, engaging Beta, and finally attacking Beta. Beta reacts by playing the suitable animation, being punched and running away. Let's see how this is achieved with xaitControl. Here we see the final state machine, the flow graph of our Alpha. It's pretty easy to understand how the behavior of Alpha works. We start in the green start state over here, follow this arrow, which is called transition, to find Beta state. If no Beta is found, we go over here and keep repeating this loop until a suitable Beta is found that can be approached, engaged and attacked. After the attack finished, Alpha thinks again what to do, decides what to do and starts over, keeping repeating this loop. So it's really easy to understand what's happening over here. Let's have a look at a Beta state machine. The Beta state machine is a little bit bigger, contains more states, but it's still easy to understand. And the nice thing about xaitControl is that it's pretty performant. Since the attack happens only in these states, we can discard all other states, which makes xaitControl very performant. So let's have a closer look at what happens when Beta is attacked. Beta reacts on this onAttacked event, which is a custom event sent by the game, going into the onAttacked state. This transition without a source state means that Beta can react independent of the state it's currently in to being attacked. Then under attack is executed, and when the attack finishes, the daily life behavior is done over. This under attack state is another state machine on itself, so you can use state machines within state machines. Let's just drill down and have a short look at it. Just by double clicking, we see how it works. Starting over here again in the green start state, after some time, we react on the attack by playing the suitable animation. We try to get away, so some distance is being achieved between the attacker and the attacked one. After being defeated, we run away a little bit further and end over here, continuing in our main state machine to attack finished. So it's really easy to understand and to model these behaviors. Let's create some more behaviors and some more observers. So we got this onHap called received state over here, reacting again with a global transition on this custom on call for help event. So let's have, for example, observers cheering when an attack happens. We just drag and drop in this state and incoming and now outgoing transition. And since xaitControl is completely data-driven, we just need to export our data. That's all we need to do, so let's start our game. Shown here is exactly the same scene as before, but with some more observers added to our scene. And now as soon as the attack happens, all the observers start to cheer according to our new state machine. Let's add another behavior to our observers. Just take the runaway behavior, drag and drop it in, add an incoming transition, add an outgoing transition. Usually state machines are pretty static, meaning same inputs result in same outputs. And that would result in artificial-like behavior. So what you want to have is usually multiple choices for AI. And this is pretty easy to achieve with xaitControl. In this onHelp call received state, we got two possible outcomes for our behavior, either cheering or runaway. The probability sliders on the right hand side allows you to easily adjust the outcomings in a variety. So for example, let's have 60% of our characters cheering and 40% running away. Just export the data again and we're all set to restart our game. So now some of the characters will cheer, others will flee. Let's see what we achieved. Now the fight starts and we see some run away, others start to cheer, just like expected. So far we have seen how to use probabilities to provide your AI with a little bit more variety. And we've seen how to use sub-state machines to structure your final state machines. Another use of sub-state machines is that it allows you to reuse already existing behaviors. For example, let's take the alpha state machine, the state machine that's responsible for attacking other characters, and add it to our beta state machine. And this allows us to have characters, beta characters, attacking other beta characters. Just drag and drop it in, and that transitions to it, an incoming and an outgoing. Keep in mind that our alpha state machine has two possible outcomings, so either beta is found and the beta is attacked, or no beta is found and this loop would be repeated. What I want to do now is, if no beta is found, I want to have our characters either starting to cheer or run away. So what I do is I just add some more transitions, one to cheer and one to run away. And now I can set from which state inside the alpha state machine these transitions will exit. So if we're going to cheer, I select the no beta found state, and the same holds true for the runaway. Just select no beta found. If we are proceeding to attack finished, I just select the decide state, which means the attack has finished. So now let's export our data again and observe the behavior in our little game. Back in our game, we'll now see three possible behaviors for our observers. Some will cheer, some will run away, and others will pick a fight. So for example, these one are two beaters where they are now engaging each other and attacking. It's exactly the same behavior as we observed with our villain before. Let's watch this again. So alpha is picking the fight, and our beaters are reacting according to our three different behaviors. Like this one over here or there. There are two different beaters picking fights. Last but not least, I'd like to show you xaitControl's integrated graphical debugger. Having a visual tool to create your behavior is less error-prone than scripting or coding, but sometimes you need a way to see what your AI is doing. xaitControl allows you exactly this. So you can set breakpoints to stop your behavior, add transitions, add states, or even add whole final state machines. Then you just connect your game with xaitControl, just by hitting this button. Now I'm informed that the game isn't running, so let's start it. And now as soon as one of these breakpoints is triggered, xaitControl gets active. Now it informs me that one final state machine is different, like the beta or the under attack, that's fine. And you see now which state currently has been executed. You can even track back and get this nice highlighted graph through the state machine, showing what happened in the past. As with any debugger, you can change variable values or investigate those. You can even block transitions from being executed, which allows you to force a distinct path through your state machine. With this tool, you got all the parameters in hand to control your AI.